Hey everybody, back again for our second YouTube. Mr. Hamilton and Penny's with us again. We last time we talked about trig graphs and what they look like. And we described two big terms on them. We described the uh, length of we described the midline of a trig graph, and we described its amplitude. So today we're going to talk about something called the period of the trig graph. And definition of a period is, and this is from our note from yesterday, but I'm going to talk about it again, is it basically, let me enlarge this here. So the period of a trig graph is the length of a cycle. So it's the time it takes to make one complete revolution. So if we take a look here, and because these things go on forever, they're a little hard to decide where they start and then where they stop. And we have two trig graphs we're looking at. We have a sine graph and a cosine graph. So I'm going to just show you here. So this upper left graph is the sine graph. And a good way to talk about the sine graph, a starting point is on its midline. And so a sine graph starts on its midline. It goes through a high point, goes back through the midline to a low point, and then stops at the midline before it repeats again. So when we talk about the period, it's this length. It's this time in blue. And the time is always on the x-axis. So it's the amount of time it takes to complete one cycle. Now cosine graph is similar, but it starts up here at a high point and it goes through the midline to a low point and then ends at its high point. And again, when we talk about period, it's the length or time on the x-axis this thing takes to complete one cycle. So period is important. We talked about amplitude before. So if I show you guys, let's go like this. So if I show you a periodic trig graph, and I'll use a couple of colors here, and it goes like this. Okay, so this is a periodic graph. It repeats forever. And if we talk about its period, that's the length in time from here to here. Okay, so as that distance increases, so if we were to draw another graph on the same axis and to increase that period length, let's say we spread it out a little bit. So maybe it was like almost twice as long. The blue graph, and the best way to think about this is sound waves. So the blue graph, as we increase or we stretch out its period, the tone of the sound decreases. But as we push it together and we look at this red graph here, the pitch or the tone of the sound would go higher. Now, yesterday, or the last lesson we did, we talked about amplitude, and that's this height, distance from the midline to its maximum. Now, the amplitude is important in sound waves also because as we increase the amplitude, let's say we made this a bit higher. So we increase this distance. As that distance increases, the volume increases. It's kind of like when Mr. Parker talks in class. He's really loud. His amplitude of his voice wave is super big. So I want to just do a couple examples with you guys. And let me see if I can minimize this. Okay, so the example, you can see Penny already fell asleep. Penny, would you need a treat here? Here we go. Penny. Oh, sorry, Penny. Here, stay with us here. We need to make sure we're engaged in the lesson. I'm not being a good teacher if you're not. So we want to determine the period of the following graph. So the best way to do that is to find a starting value. And again, these things are periodic, so they repeat forever. You have to decide a starting value. I like to start when x is 0. So we're going to trace one complete cycle. I know it stops right here because this is the midline of the graph. I have a high and I have a low. It always completes one cycle after it does one high and one low and goes back to the midline. So now for its period, I just follow it down to the x-axis here. And because I started at 0, that makes this distance 2 pi or whatever this value is right here. Now I wouldn't have to start at 0, but then I would have to do some subtraction. And yeah, it's not very fun when we subtract with fractions. So I like to start at 0. Let me show you another example here. Again, determine the period of the following graph. So I'm going to start at 0. So this is actually a reflection trig graph, but that's okay. So it's going to start low, and I'll follow. It goes through the midline. Here's its high point, back through the midline, and before it repeats, it stops here on the low value. So because I started at 0 here to find the length on the x-axis, I just need to look at this value. In this case, this period length is pi. So big idea from today is how to find the period from a graph, and the best way to do that is trace one complete cycle. Use your finger, use your eyes, and then locate the distance on this x-axis. And it works if you want to start here, and we'll trace, we'll trace one complete cycle. It goes through a high and a low, it ends here. And so the only difference is to find the distance here, I would need to subtract. So take the absolute value of these, that's 2 pi, that's pi, 2 pi minus pi is 1 pi, or pi. So it gives us the same value. It's easier if you start here on the x-axis. That's it. Penny, you got anything to say about that? She's out. Good luck, everybody.